This is question 13 and it's a question about bearings. And what we're told is a diagram shows 2 points A and B on a map. And the map has got a scale of 1 to 25,000. And we've got to find the bearing of B from A. So because it's written that way, B from A, it means that we're actually stood at point A and we want to know what the bearing of B is from A. So what I'm going to do first of all is I'm going to just join those two lines together, B and A. And in fact, I'm going to extend that line just to make it easier for me because I'm going to have to measure the angle later. And I'm also going to extend this north line here. And for a bearing, what that means is I would be originally stood at my start point there, which is A, and facing north. And then I would be turning clockwise until I face my target, which is point B here. So I'm interested in this angle. So notice I've turned in a clockwise direction. So I turned in that direction, which was clockwise. And so I'm going to need a protractor for this. So here's my protractor. And what I'm going to do is I'm going to move the cross point on the protractor so that it's at point A there. And then I'm going to rotate it until the 0 on the outer scale there is facing north. So it's lined up with the north line. And I'm interested in the angle then that the line from A to B is at. So we can see that it's there. It's actually at 30 degrees. So that's my bearing, is 30 degrees. So I can write that on there. That's 30 degrees. And the thing with bearings, we have to write them as 3 figure bearings. So because I've only got 30 degrees is two digits, what I need to do is just put a 0 in front, and 030 is the bearing of B from A. And then in part B, I've got to work out the real distance between A and B. So I need to know what is this distance here, the real distance between A and B. So first thing I should say is, because I've pasted this onto a whiteboard, the distances might be slightly different to what they would be on the paper if you do it yourself. But I'm just going to go through the method that we would have to do. So for this, I'm going to need a ruler, and I'm just going to line this up. And if I look on the scale, I can see I've got 30 millimeters, which is actually 3 centimeters. So the distance on the map is 3 centimeters, but then I've got to use this scale, which tells me that 1 unit on the map is worth 25,000 units in reality. So in reality, that distance is 3 times 25,000 centimeters. So if I multiply that out, then what I'll get is 75,000. So 3 times 25,000 is 75,000. But that's in centimeters. And what I need to do is convert it to kilometers. So a useful way to do that is first of all convert it to meters, and then from meters convert it to kilometers. So if I've got a number that's in centimeters, because there's 100 centimeters in a meter, to convert it into meters I need to first of all divide by 100. So if I take my 75,000 and I divide it by 100, it's the same as just moving the decimal point 2 places back, and it would go after that first 0. So in meters, the distance is actually 750 meters. And then if I want to convert it into kilometers, because there's 1,000 meters in a kilometer, I need to divide the number by 1,000. So if I do that, again, I can just move the decimal point, and this time I've got to move it 3 places. So 1, 2, 3. And I can see the decimal point goes in front of the 7. So it's actually 0.75 kilometers is the distance in real life. So on the map, it was only 3 centimeters, but in reality, the distance is 0.75 kilometers. So I hope that's been helpful to you. And if it has, please consider subscribing to our channel and also giving the video a thumbs up. Thanks for watching.